Hello, everyone, and welcome. I'm Samantha, a member of the ICCT Communications team. Thanks for attending today's webinar. The webinar is being recorded, and we will send out a recording of the webinar in the coming days. Everyone does have their microphones on mute, but if you do have questions, feel free to write them in the questions box in the control panel to the right of your screen. After the presentation, we will have a few minutes to answer questions from the audience. Today, we're going to talk about global scrubber washwater discharges under IMO's 2020 fuel sulfur limit. The presentation is presented by Ludmilla Assapova. Ludmilla is a researcher on the Berlin and Marine teams. But before presenting Ludmilla, I'd like to introduce Brian Comer, Marine team lead, for a few words. Brian.
Thanks, Samantha. In its effort to reduce air pollution, the International Maritime Organization has created a new and growing water pollution problem. And until this study, no one had estimated the magnitude or the distribution of washwater discharges around the world. Today, we'll show the extent of the problem and we'll suggest ways that policymakers can protect their waters from scrubber washwater. I'd like to turn it over to the lead author of the study, Dr. Ludmilla Assapova, to present our results. So over to you, Ludmilla.
Thank you, Brian. Good afternoon, everyone. My name is Ludmilla, and today I am presenting the results of our published report on global scrubber washwater discharges assessment under the new IMO regulations. As many of you are already aware, the new IMO sulfur cap restricts maximum allowable sulfur content of fuel to 0.5% instead of 3.5%. This criteria can be met with using an alternative low sulfur fuel or a compliance technology or so-called scrubber. Because scrubber is a more affordable alternative than cleaner fuel, more than 4,000 of them were installed by 2020. You can see it in this plot. This is 4 times higher intake than in the previous year. And just 10 years ago, only 11 ships were fitted with scrubbers, and now it's more than 4,000. So what is a scrubber? It is a technology that can be used along with heavy fuel oil and still meet 2020 sulfur cap requirement. It removes a portion of the sulfur from the exhaust gas before emitting it. Scrubbers can be of different types, open loop, closed loop, or hybrids. It depends on how they eliminate sulfurs. An open loop scrubber on the right side uses large volume of seawater for processing, while a closed loop scrubber, you can see it on the left, uses a special alkaline water solution for the same purpose. And both processes are actually not emission free, and they can form sludge and wash water, as you can see in this graphics. The wash water can be treated, but this is optional and often it's not actually the case. The ICCT published a report providing detailed information on washwater content. You can see the link on the bottom of the slide. Our data showed that scrubber washwater is commonly more acidic than the surrounding seawater. It can contain polycyclic aromatic hydrocarbons, nitrates, sulfates, and heavy metals. And some of the elements accumulate over time and can cause various toxic effects. For example, only a few months ago, a study was published by Norwegian and Swedish researchers, and they showed that sampled washwater was highly toxic to the zooplankton, which is an important base for the marine food web. And despite all this concerning data, till now, we were not really aware what washwater volumes will be emitted by the current marine fleet globally, and where will be the pollution hotspots, and what territorial, sea, or marine protected area will be affected the most. And to answer those questions, we modeled the scrubber washwater discharges distribution and mapped out and ranked washwater discharges by ship type, by flag state, by national water and major ports. For that, we used several comprehensive data sets and developed the following model. Firstly, we used Clarkson World Fleet Registration dataset for identifying the ships that installed scrubbers by the end of 2020. And after that, using the ship individual numbers, we found them in AIS dataset provided by the Exact Earth. We modeled power demand of these ships using our previously developed SAFE model, or systematic assessment of vessel emissions. This model allows to calculate power demand per hour for each ship in the dataset. And then, knowing the ship energy demands, we estimated scrubber washwater discharges using the formula presented here. For the washwater flow rate, we used IMO recommended values. It's, as you can see, it's 45 ton megawatt hours for open loop mode and 0.1 ton per megawatt hours for closed loop mode. Now it is important to mention here that these results model pre-pandemic ship traffic pattern. We used 2019 ship traffic as a pre-pandemic baseline model of ship activities and estimated the mass of washwater discharges by the ships that had fitted scrubbers by the end of 2020. And moving on to the results, of the approximately 82,000 ships that were sailing in 2019, we identified 3,628 ships fitted with scrubbers. This number is a little bit lower than the number reported by DNVGL or mentioned before, but since then, Clarksons have added additional ships with scrubbers to the database. Of all reported scrubbers, 85% were open loop type, 14% were hybrids, and only 1% was closed loop. Bulk carriers, container ships, and oil tankers represent 74% of all scrubber installations. Cruise ships, despite the small absolute numbers of installations, have the highest proportion of fleet fitted with scrubbers. For example, if you look at this plot, you can see that the bulk carrier have the highest absolute number of installations, but only 10% of all bulk carriers actually carry scrubbers. And cruise ships have one of the lowest absolute numbers of installations, but 34% of all cruise ships use scrubbers. We estimated that 10 billion tons of scrubber wash water will be discharged within a year globally. And this is nearly equal to the all cargo mass of the global shipping sector carries, which is around 11 billion tons in a year. This estimate excludes around 400 million tons of discharges that will not be emitted thanks to the national level regulations. 80% of or 8 billion tons of wash waters will be released within 200 nautical miles from the coastline. In the map, you can see that the worldwide discharges form 3 general hotspots. One is in the Caribbean Sea in the west, then Baltic Sea, North Sea, and Mediterranean Sea in the European part, and Strait of Malacca in the east. The top 5 countries with the largest wastewater discharges in the territorial and internal waters. They are United States, United Kingdom, and Italy, Greece, and Japan. You see it in this small table on the right. United States is number 1 in our ranking list. And you can see that the discharge absolute volume is very high. But this is mainly because United States has one of the largest territorial sea areas in the world. The United States wastewater discharge per unit area is relatively small. The United Kingdom, on the other hand, is just slightly below the United States in our ranking list, while the territory is actually 4 times smaller. More than a half of these discharges belong to the United Kingdom overseas territories. And for example, only Cayman Islands Territorial Sea will receive 44% of all wash water emitted in the UK. I have to mention that even though you cannot see Singapore in the ranking list, this is only due to a very small territorial sea area. However, Singapore actually holds the first place for the highest concentration of the wash water. It has around 15,000 tons per square kilometer. And this is despite the fact that Singapore actually already partly regulates scrubber wash water discharges, and they banned wash waters in the ports. The next map shows wash water discharges in ports worldwide. We estimated that 300 million tons of wash water is expected to be dumped in the ports worldwide. As you can judge, the pattern is very similar to the previous map, with 2 exceptions. There are large discharges as well in Canada and in Australia. In the map, you can see names of 10 ports with the highest wash water discharges, and among them are Port of Vancouver, it's number 4, and Port of Sydney. Overall, these top 10 ports will receive 83 million tons of wash water, and half of it will be dumped in only one port, in Port of Georgetown in Cayman Island, this island that I just mentioned before. This is due to heavy cruise shipping traffic in this area. Out of 50 scrubber-equipped ships identified in the Port of Georgetown, 49 were cruise ships, and there is a reason for that. As shown in this plot, cruise ships actually spend 25% of their time in port and have the highest in-port energy consumption. Average power consumption for cruise ships in port is 12 megawatt-hour, compared to oil tankers, for example, which is next on the graph, and consume on average 4 megawatt-hours in port. It makes cruise ships the largest source of washwater discharges in ports. And overall, cruise ships were responsible for from 74 to 100% of all discharges in the top 10 most polluted ports. Finally, we were able to estimate how much washwater being discharged in 15 particularly sensitive sea areas, or PSSAs. These areas have a special shipping navigation status, and it's designated by the International Maritime Organization because this area includes threatened reef system and endangered marine life. And we find out that more than 600 million tons of washwater will be emitted within PSSAs, and 91% of this washwater will belong to the Western European waters and Baltic Sea PSSAs. So it's the most polluted ones. The Great Barrier Reef PSSA has the third highest discharges, or 32 million tons, which seems to be driven mainly the three coal exporting ports you can see in the map. We were able to identify more than 500 ships operating with scrubbers within the Great Barrier Reef PSSA. Finally, Free Caribbean PSSA region did not reveal large discharges by mass, but actually this is only due to their very small area. They consist only 1% of all PSSA. So this small number, this small discharges in Caribbean Sea actually reflects the lack of regulation of threatened marine life in the Caribbean region. And because you can see at the Caribbean inlet that the traffic, the shipping traffic is quite large there, it's quite intensive. And summing up all these results, based on the presented analysis, the ICCT formulated a few policy recommendations that they can see can be relevant. We believe that issue can be actually addressed at the different levels. At the international level, the IMO could consider to ban scrubber discharges, at least in the PSSAs and near shore waters. Also, individual states can be proactive. They can also ban scrubbers, washwater discharges in the national waters, actually just as it was already done by some states. Also, some on-land facilities should be installed for sludge disposal. And nearby countries could work together for harmonizing scrubber discharge bans. For example, Malaysia, Indonesia, and Singapore have already prohibited open loop scrubbers in their ports. But this does not extend in the Strait of Malacca, one of the hotspots, which passes through each country's territorial seas, and it's expected to receive the largest concentration of washwater discharges in the world. So the joint effort would help actually to eliminate this type of impact. And finally, at the port level, scrubbers can also be banned by the individual states. Besides, the cruise ships could plug in into onshore power facility while in ports where it's available, because this way an engine is turned off and washwater pollution is not happening while ship is berthing. And eventually, the washwater and sediment pollutants can be monitored in ports by the port authorities. This can be done for making sure that the pollutants do accumulate over time, do not accumulate over time, and not cause any damage to marine life or public health. So thank you very much for your attention. This report is published. It's already published on our ICCT website. You can see the link below. It includes an interactive map as well that has all the detailed information on washwater discharges around the world, and it can be accessed for free and explored for the policymakers. And now I'm free for any questions. Thank you for your attention.
Thank you, Ludmilla. It's a very informative presentation. And now we will move to the Q&A section of the webinar. So remember, if you have any questions, just write them in the questions box and we'll answer as many as we can. The first question is for Ludmilla, is how many countries have restricted or banned washwater discharges at the moment and why?
Okay, that's a very good question. In our research, we accounted for 16 countries that banned washwater discharges at the time when research was done. So it was up to June 2020. But currently there are around 30 countries that regulate washwater partly or completely in the territorial seas. And this number is rapidly growing.
Okay, thank you. Next question. I think both you and Brian will be able to answer this. When separating washwater discharge by country, is it the place where the washwater is dumped, or is it tabulated by what country the vessel is registered in? So in other words, is the US the place where the most washwater is dumped, or is it the US vessels doing the most washwater discharge?
So if I understand correctly, the question is that when you know who is responsible for washwater being dumped in the territorial sea, right? The thing is that the washwater can be, if it's not banned in the territorial sea, it can be dumped in territorial sea. So it's not regulated, but it is monitored. There is a certain IMO non-regulations, like non-mandatory guidelines that requires monitor the content of washwater. So this is a job of the ship of doing it and report it in the port. I don't know, Brian, if you can add anything to it.
Yeah, and so the United States ranks first in terms of how much washwater is discharged inside of its national waters. If you look at it by flag state, which is what I'm showing here, this is figure 6 from our report, you can see that the ships that are registered to Panama, Marshall Islands, and Liberia, those ships account for 40% of washwater discharges worldwide. So and Panama is particularly interesting because Panama has banned open loop scrubber discharges in the Panama Canal, but the ships that are registered to Panama are responsible for 18% of washwater discharges globally.
That's interesting. It's a very good illustration of that. Thank you. The next question I'll ask is, of the 4,000 odd ships installed with scrubbers, how many are with open loops?
Sorry, can you ask again? I can't.
Yeah, sure. So
Yeah.
of the ships installed with scrubbers, this person has estimated there's about 4,000 of them. How many of them have open loop scrubbers as opposed to closed loop scrubbers?
85% have open loop scrubbers and around 14% have closed loop scrubbers. No, sorry, about it's hybrids, yeah. So 85% is open loop, around 15% hybrids, and the closed loops are the least common ones. It's around 1%, I believe.
Oh, wow. That's really interesting. I did not know that. Brian, go ahead.
And as Ludmilla was saying early on in the presentation, the mechanisms for the closed loop operations are much more complicated than the open loop. And so for the closed loop, you need to have the alkaline solution. You're not just using the ambient seawater. You've got to filter out some of the particles and collect it as sludge to keep the recirculating water more or less clean as you continue to operate it. And then whatever sludge you gather on board when you're operating it in the closed loop mode, that can't be dumped overboard in that concentrated form. It has to be disposed of on land. And so you need to find an on-land reception facility for it as well. So because there's no prohibition globally on using open loop scrubbers, then they're the most popular system. And the hybrid systems give you a little bit of insurance in case you encounter a locality that has restrictions just on open loop scrubber discharges. You can switch to closed loop mode. But as Ludmilla was saying, even in closed loop operations, there's this concentrated bleed off water that is discharged overboard. So it's a lower quantity of water discharged overboard, but it's more concentrated with the PAHs and the heavy metals. So it's still a concern.
Mm-hmm. Yes, and many studies actually showed that closed loop scrubbers bleed off water is way more toxic than wash water from the open loop scrubbers. Plus, with the sludge, there is a problem with the disposal. It's not available everywhere, and it's not cost-free. So some ships would have to carry sludge, and there's a lot of logistical issues with that. I think that's also the reason why open loop scrubbers are more common.
Yeah, that makes a lot of sense. A different sort of question. Someone has asked, what evidence do you have that wash water volumes being discharged are causing harm to the environment?
Well, we published a report before this report. In one of my first slides, I left up the link. So we assessed we did a literature review of all available publications on the toxicity of wash water. And there are some independent studies showing that it can be highly toxic to the marine organisms. Like one of the studies I mentioned in this presentation was published only 3 months ago. And it shows it's as toxic to the marine organism as crude oil. But the publications, it's relatively new issue, so there's not many publications, but some that are out are concerning.
Yeah, and if I can add to that, one issue is that when the IMO's numeric discharge criteria were established for how much PAHs or turbidity can be in the wash water discharge, that was agreed to in 2008, and it was based on 3 scrubbers at the time, 2 of which were prototypes. And although those guidelines have been reviewed 3 times since then, most recently in 2020, they've never been strengthened. The idea in the beginning when these discharge criteria were established was that they'd be evaluated over time and strengthened, because when they were established, you have 3 scrubbers and you don't really know what they're capable of. What isn't accounted for is accumulation of pollutants in the sediment, the issue of a number of ships calling on the same port multiple times and continuing to discharge, especially in shallow areas. So the discharge criteria are based on concentrations. They don't account on total mass of pollutants or account for the cumulative effects over time. And if you just think about it, if you're discharging polycyclic aromatic hydrocarbons, this is the residue that you capture from burning oil, and then also heavy metals, including mercury, and just discharging wash water that's more acidic than the surrounding seawater. It's not too big of a leap to think that that could have negative impacts on marine life and marine ecosystems. And now we're seeing more and more independent studies coming out to confirm that suspicion.
Yes, thank you, Brian. And also some research actually highlighted that there is no cocktail effect factor considered, you know, when like some of the elements of wash water by themselves might not be harmful, but altogether as a cocktail, they can have a strong toxic effect. And actually in our previous research, we showed that only 70% of all samples published meet pH criteria.
Mm-hmm. That's interesting. Just for anyone who is curious about those previous studies, I will be posting the slides on the event page after the presentation. So you can feel free to search for those links that Ludmilla had mentioned and added in her presentation. For the next question, Are there ongoing or planned studies with ship operators to collect real-world operational data to compare against what is estimated by the SAVE model for various ship types and operating modes?
I think this kind of data would be hard to obtain from the industry. If it was publicly available already and it's published somewhere, we would be happy to evaluate our results with the real world data. We'd be happy to do that.
And we were able to find some data that was published by researchers looking at the washwater flow rates, for instance. The average flow rate that we were finding in the literature was actually twice as high as we assume. It's about 90 tons per megawatt hour. But what's really important is the total mass of pollutant that's being discharged and the acidity of the washwater. So in our previous study, we looked at the available literature and we came up with some emission factors for different pollutants and also estimates of PAHs for closed loop and open loop scrubbers. And that was for a consulting report that we did for Environment and Climate Change Canada.
Okay.
Yes, the link is on this presentation.
A question, I don't know if this is maybe an easy question or not for you guys. Do we have an estimate of the share of washwater that does not end up in the sea?
That's a very good question. We never thought about it. I think in the open loop scrubbers, everything is end up in the sea. They do not collect anything on board. For the closed loop scrubbers or hybrids in closed loop mode, they do have sludge and not the wash water per se. So I would say that this number would be close to zero. Correct me, Brian, if I'm wrong.
Yeah, I would agree. But we have seen from the local prohibitions on scrubber discharges that we've avoided about 4% of the discharges that would otherwise have happened. So we can see the impact of policies that restrict open loop scrubber discharges. I should also just point out that it's important that governments recognize that they should, if they're looking to protect their waters from scrubber discharges, that they shouldn't just restrict open loop discharges, but also closed loop. So closed loop makes it sound like there's no discharges, but that's not the case. There's still discharges unless they're operating in zero discharge mode where they're collecting the bleed off water on board, but there's a limited tank capacity for that. And then also, you know, they would need to be required to do that. They won't, you know, just normally do it by themselves unless they're mandated to do that.
So a follow-up question with that, are there any countries that currently prohibit the closed loop water discharge?
Yeah, there are some countries that I can't name it from the top of my head, but it is in the report. You can check this out later. There are countries that actually ban both open loop and closed loop scrubbers, and there are countries who ban only open loop scrubbers. And the second type is more common. Usually countries ban only open loop scrubbers.
Okay, thank you, Ludmilla. I think we have time for about one more question. This one is more on the economic side. It's asking, the total investments in scrubbers already runs into billions. So what is the ship owner's response to the scrubber technology that was suggested by the IMO as one of the choices as far as the IMO sulfur 2020 deadline was concerned?
I can take that one. Yeah, so scrubbers were allowed as an alternative compliance option globally and on high seas, but countries can and have already prevented their use in their waters. And I've written in a previous blog post that we recognize that there has been significant financial investments in scrubbers so far. The scrubbers that we have today, if we were to convert them to closed loop mode and then operate them in zero discharge mode near shore, that still allows the companies that have already invested in scrubbers to see a return on their investment. And the pace of IMO regulations, if IMO were to decide to ban scrubbers globally or not allow them as an alternative compliance option, once IMO were to decide that, it still takes another 2 years for that rule to be enforceable, at least 2 years. And the payback period for scrubbers, depending on the fuel price spread, can be as little as 9 months. And even at low price spreads, it can take a couple of years. So the return on investment for ships that already have scrubbers is already being paid back. What we can do is prevent new ships from installing scrubbers in the first place, and instead using the lower sulfur marine gas oil.
Yeah, I can add also at the end of the day, even though it's more than 4,000 ships installed scrubbers, it represents around 5% of the global fleet. So it's still there are 95% of ships that are thinking what they should do. Should they install scrubbers later on or turn into alternative fuels? And the answer is better to turn to the alternative fuels in this case. And also on the economical side, I actually encountered 2 peer review publications that look at the cost-benefit analysis of the scrubbers and the compliant fuels, low sulfur fuels. And they actually show in the long run, it's a worse investment than installing scrubbers because of certain corrosion issues and certain maintenance issues related to the scrubbers.
Mm-hmm. Okay, thank you to both of you. I do want to ask just one more question. We'll end on this one. I think this also relates back to some of our other studies. Do you think that ships should change back to the Vlsfo/LNG option to meet the guidelines?
Yeah, for ships that are running LNG, they're not going to have scrubbers. We've shown that LNG, because methane is not a regulated pollutant, that ships are using engines that leak a large amount of unburned methane that we call methane slip into the atmosphere. And so it's meeting IMO's carbon dioxide regulations for new ships and meeting the sulfur regulations. But as a consequence, it's emitting large amounts of unburned methane. It also meets the nitrogen oxide limits, which is actually one of the reasons why they emit so much methane. So right now, the cleanest fuel option is marine gas oil, so 0.1% sulfur or lower fuels, and that's what we would suggest that ship owners be running on. On the open ocean, it's going to likely be Vlsfo, the 0.5% sulfur fuels that ships would use, but that would avoid the wash water discharge and water pollution problem.
Okay, thank you so much, Brian. And thank you again to Ludmilla for the presentation, and thanks to all of our participants. There were a few more questions that were asked. I'm sorry we weren't able to get to those, but I do encourage you to reach out directly to Ludmilla or to Brian to follow up on some of those remaining questions. Remember to follow us on Twitter, and again, just let us know if you have more questions. Thanks again, and we hope to see you soon.
Thank you, Samantha. And thanks, everyone.
Thanks, Samantha. Thanks, everybody.